Let the adventure continue as we move into TCP/IP subnetting part 2. What we're going to do is build on the foundation that we laid in part 1, which was the 3 steps of subnetting based on the number of networks, as in we had the number of networks that we needed and figured out our subnets from there. Well, this video changes that scenario a little bit, flipping it on end and saying we're going to subnet based on the number of hosts rather than the number of networks. Now, this assumes that you've gone through part 1, so I'm not going to spend as much time reiterating the 3 steps, but I guarantee you that seeing this will not only help you with the scenarios we're presenting right here with these 4 different scenarios, but you'll also get a better feel for even the scenarios from part 1, because it is the same 3 steps in a very similar process. So let's get going. I'd like to start things off by a network scenario that's very similar to the one that we started the previous video with so that you can see the differences. We have an organization that's purchased a Class C address, again 216.21.5.0, and would like to use it to create networks of up to 30 hosts each. So if you think back before, we were trying to work through this scenario based on creating 5 networks. 1, 2, 3, 4, 5. But this scenario says I would like to create networks of 30 hosts each. So they're more focused on the number of hosts per network rather than the number of networks. When working through a subnetting problem of this slant, the steps are nearly identical as before. Well, I should say the steps are identical. There's just a slight tweak as to what we're looking at. So step 1 was to determine the number of hosts and convert that to binary, just like we saw with the number of networks. Here's our Class C subnet that we purchased. We know that we're trying to find networks of 30 hosts per network. So that's our host. Number of hosts, 30. With that in mind, let's break that down using the binary 128, 64, 32, 16, 8, 4, 2, 1. Now, with these numbers in place, again, we realize that we're only after the number of bits. So we don't need to figure out the whole number, although I will just for this example. 16 plus 8, that's 24, plus 4, that's 28, plus 2 more, that's 30, and then we have a 0 for the 1. So the actual binary number for 30 is 0001111. But again, being after that we're only after the number of bits, we're really focused on it takes 5 bits to get the number 30. Step 2 is then to reserve the bits in the mask and find your increment. Here's where the slight tweak comes in. I'm going to take the original subnet mask, and we start off with a Class C example again, 255.255.255.0, and write that in all binary. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. I'll show you how to improve your speed on that in just a moment on the next scenario. So we're looking at this right now in terms of this is our original subnet mask, and we need to do subnetting. Now, in the previous video, we were focused on I need more network bits because I needed 5 networks or 30 networks or 100 networks or whatever the scenario said. I was more focused on getting networks than I was on how many hosts were on each one of those networks. In this style, we're more focused on how many hosts we're getting. And yes, we're going to be doing subnetting, otherwise we wouldn't be here in the first place. We want to break it into networks, but we're not as concerned with how many networks we get as we are with how many hosts can exist on each network. So when you're thinking of this, I want you to just say in your mind, whenever you see how many hosts per network, just kind of like save the whales, save the hosts. You can scream it out loud, whenever, wherever you want, because what we're focused on is saving the hosts. 1, 2, 3, 4, 5 to be exact. Instead of working from left to right saying I need 5 more network bits, I'm saying I can't get the number 30. I can't get 30 hosts with any less than 5 bits. We know that the host bits are 0, so we're saving 5 of them. Save the host. You can say it out loud. Now, once we've saved the 5 host bits, the rest of them can become network bits. It can move over to the network side, the dark side of the force, because we're still doing subnetting. We still want to subnet, but we're now focused on how many hosts we get rather than the specific number of the networks. So with that in mind, that is the only difference. So here we go. Let's work through the subnet mask. Our new subnet mask is 255.255.255, and if we convert this one back to decimal, that will be .224 if we add up all those numbers. Or if we were using the bit notation, that would be a slash 24 plus 3 more, slash 27. Our increment is the lowest network bit, which is a 32. That's our increment. Now we can find our network ranges. We started with 216.21.5.0, and then we just start adding 32. 216.21.5.32.5.64.96.128.160, and you can just keep going, far as down as you'd like to go. Fill in the end ranges. Last IP address before 32, 31. 464, 63. Now, I'm really shorthand writing this right now just to save the time, but this is filling in the end range for each one of them. It goes from 216.21.50 through 216.21.531. Can't use the last one, can't use the first one, so we actually get 1 through 30 that are usable in between, which is exactly the number of hosts that we were looking for. Just how many subnets do we get? 2 to the power of, well, we introduced 3 more subnet bits. 2 to the power of 3 will end up being, this is 2 to the power of 0, 1, 2, 3. So we end up with 8 total subnets if we were to work this down the whole way. And if we were to do 2 to the power of 5, because there's 5 host bits that we saved, minus 2, that leaves us with 30 hosts per subnet. Now you might notice that I'm moving through these a little bit faster because we've seen the foundation of the previous video where I work through them step by step, working very slow, explaining everything as I go along. What I'd like to do here is not only, of course, introduce the new concept, but to get you faster at this as well, to move a little bit quicker through these scenarios. So if it seems like I'm going faster, I am. We have another scenario, same style. We've got network scenario number 2, class C example. We have the network 195.520, and the organization is looking for 50 hosts per network. So let's start it off again. Determine the number of hosts and convert to binary. I'll write up our binary chart over here, 8, 4, 2, and 1. We have 50 hosts. So I look right here, no, no, yes. Our first one goes at 32, so I immediately know it takes 6 bits to get the number 50. Sorry, let me just change my font that I'm writing with so it's a little thicker so it looks a little neater. We've got 50 hosts equals 6 bits. Now, what we need to do is reserve the bits in the subnet mask and find our increment. So our original subnet mask is 255.255.255.0. I mentioned that I was going to show you a way to shorten this down as well. Once you're comfortable doing this, you can look at this and say, well, I can't really change the 255s, right? Because since this was a class C address to start off with, I can't change the original subnet mask, meaning I can't move it backwards, otherwise it wouldn't be a class C address. So the way I do this is I just think, okay, so that would be 24 ones, dot, 1, 2, 3, 4, 5, 6, 7, 8 zeros. Because the zeros are really your playground. That's where you can work. You can't change the original 24, so you can just kind of jot those up there like that. Just quick shorthand instead of counting them all out. Now, you have to ask the question, are we creating more networks or saving the hosts? And you have to put your hand in the air when you do that. It's required. And we look and it's after the number of hosts. It's 50 hosts per network. So we are saving the hosts. 1, 2, 3, 4, 5, 6 of them have been saved because we can't get the number 50 with any less than 6 bits. The other 2 host bits can change over to ones so that we can do our subnetting process. Once we do that, we know that our subnet mask will be 255.255.255 dot, and we have 2 bits. If we add those together, that would be dot 192 is our decimal subnet mask, or a slash 26, which is the 24 original ones of the class C plus two more that we just added when we did our subnetting, /26 mask. Our increment, boom, 64. Box, 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 box. That is our number that we can use to find our ranges. So we say 195.5.20.0. Just start adding 64 to the fourth octet because that's where we're at. 195.5.20.128.192, and if we add 64 to 192, we'll actually get 256. Now, immediately when you say that, and by the way, this is the same all the way down, just shorthanding it here. When you see 256, you should immediately go, okay, bing, I must have reached the end of something right there. So I just start filling in the end range. We got 63, whoops, 127, 191, and this goes up to 255. There is no 256 because I'm done, meaning I've reached my 4 network ranges that this will give me. I'm done. You might remember from the previous video where we actually started carrying over to the next octet. Well, you can't do that here because you started with a class C address, meaning you can't change the original network that you were given. You've just subnetted into 4 networks. And if you look at that, 2 to the power of x being the subnet bits, so it'd just be 2 to the power of 2. That's 2 times 2 is 4. So that tells you you only get 4 network ranges with, it'd be 2 to the power of 6 minus 2, you actually end up with 62 hosts per subnet. Pretty cool, huh? Now, a lot of this stuff that I'm doing, like adding 64 plus 64 plus 64, just comes from doing this 100,000 times. You'll, as you do this again and again and again, you'll practice. You'll get used to seeing what typical subnet values are, to where you can just see the 2 bits and go, oh, that's 192. As a matter of fact, the longer you do this, I'm to the point in my subnetting where I've practiced this enough, and obviously teaching helps. So I'll tell you what, find a family relative and teach them how to subnet. They'll love you for it and you'll learn it even better. But teaching this, I can just look at bits and say, oh, that's 192. It's kind of like, have you ever seen The Matrix, where the guy's looking at the matrix in an encoded format, and he said, I don't even see the code anymore. I see a guy, a girl walking, a blonde, a brunette, it's just, he stared at the code for so long, it kind of fried his brain. You will get to the point where your brain is fried, and you will master subnetting. Now, you might be noticing, as we're working through these, I am emphasizing speed. Let me take just a moment and tell you why. Speed in the real world is not as critical. It's not like you'll be walking into a job where they're like, subnet this now, you've got 30 seconds, and that's what you've got to do. I just know that a lot of you are preparing for the Cisco certification exams. And if you are getting ready for those, speed is of the essence. ccent, ccna, and even ccnp, just about anything you do in the Cisco world will have subnetting involved in it, and you'll have to do it and have to do it fast. So just to give you an idea of where we've come from, I'm always watching the clock when I'm recording to make sure that we don't get too long or too short or things like that. And when we first did the subnetting examples, when we were in the previous video, we were at about 11 to 14 minutes per problem as I was working through and explaining what I'm doing as I go. The 2 problems that we've done so far, the 2 scenarios, we've spent, the first one was 5 minutes and the last one was 4.5 minutes working through those. So my recommendation is when you're working through these, obviously you're not going to have a voice in your head, well maybe you will, but explaining it as you go, and you'll be able to write much faster. But I would gauge your time and try to aim somewhere between 2 to 3 minutes per problem when you get to one of these. That's when you know you've got it fast enough to prepare for the actual certification exam. All right. Network scenario number 3. We've got now a Class B network. I've changed it up a little bit. And someone was reading Cisco best practice documentation, and now it says, I need 500 hosts per subnet. That's what Cisco says it should be the maximum. So now we go with our 500. Write out our binary chart. 1, 2, 4, 8, 16, 32, 64, 128, but I know I must go further in order to get the number 500 because that's above 8 bits. So I go 256 is my next one. Double that, and you've got 512. And immediately I can stop there because I've passed my 500. Now, that's not where my first one goes. My first one goes right here because I can't subtract 512 from 500. So just by drawing my initial one, I can see that it's going to take 9 bits to get the number 500. Second step, reserve the bits in the mask and find your network range. So original subnet mask 255.255.0.0. We are going to write that in binary, which is 16 ones dot 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. You don't want to shortcut the zeros because that's really where you work. 8. So we've got our 16 zeros. Now, are we creating 500 networks or saving the hosts? Saving the hosts. Not only is it more fun to say, but it's more fun to do. We have 9 bits right to left. 1, 2, 3, 4, 5, 6, 7, 8 dot 9. We've crossed that octet boundary. The rest of them can become 1. 1, 2, 3, 4, 5, 6, 7. That was the rest of those bits that were in the third octet. So with that in mind, I can look and say my new subnet mask is 255.255.254.0 is that guy, or a /23. I just think of a class C address with all these being 1 is a /24, so we subtract 1. Our increment, circle that guy is 2 in decimal. So we look at what octet that increment is in. It's in the third octet. So I start down here with 150.5.0.0, and I'll increment in that third octet. 150.5.2.0, .5.4.0, 6.0, 8.0, and so on we go. The end range goes through 150.5.1.255. This goes through 150.5.3.255. This goes through 5.255, and so, oops, 255, and so on and so forth. We go down the way. If you were watching the clock on that previous network scenario number 3, it was 2 minutes, 54 seconds we took once I got out of my, once we started actually working on the problem. Pretty good. That's the kind of time frame you need to be looking at for these. All right, network scenario number 4. Class A address, we have 10,000 and need 100 hosts per network. So 100, how many bits does it take to get that number? 128, 64, 32, 16, 8, 4, 2, 1. Our first one goes right there, so immediately I know it is 7 bits. Step 2. Our original subnet mask was 255.0.0.0, which is 8 ones dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Can't really shortcut class A subnet masks. So we've got 24 zeros that we're working with. So with that in place, we know that we are needing 7 bits and that we're after the number of hosts. So save the hosts right to left. 1, 2, 3, 4, 5, 6, 7. 1. So that's our 8 bits of our last octet. What happens to all the rest of these bits? They change over to 1s. So we did quite a number of subnets when we went with this class A address. So we ended up going to 255.255.255 dot, and then the last octet is 128. Our increment is, circle that, 128. Happens to be the same as our subnet mask. So now, with our network ranges, we start with 10,000. Now, to find out where to increment, we need to look at where our increment is at. It's in the last octet over there. So I say 10.0.0.128. The fourth octet is where I increment. 10.0. Oh, stop right there. If I add 128 to 128, I'll get 256. I know that's not possible. So if I fill in the end ranges, I'll have 128 to 128 120 or 0 to 127 is the previous one. This goes up to, if the next one was 256, this would be 255. So again, do that. We did this in the previous video. Just kind of add the 1, carry it over to the next octet. We start with 1.0, 1.128, 2.0, 2.128, and so on and so forth we go down the way. Fill in the end ranges. This goes through 10.1 or 10.0.1.127 through 10.0.1.255. Sorry, I was trying to beat the clock. I'm sorry, but that's how we were going to work this. Sorry for the extreme shorthand, but this is working through a Class A example, and we would keep on going, keep incrementing through all of the Class B and C octets. So if you wanted to find how many subnets you would have, it would be 2 to the power of, we converted 1, 8, 16, 2 to the power of 17. So that'd be 17 bits total. I had to think about that one. Will tell us how many networks you'll have. Thankfully, if you're preparing for the exam, they will never have a question asking you that kind of math without a calculator. So I'll do 2 to the power of 17 equals, 131,000 subnets are at our disposal when we subnet a Class A address like that. Excellent. At this point, you should be getting a little better feel for how this subnetting works. As I did in the previous video, I have an on your own section. It's essentially homework to work through 4 different examples of this time breaking into networks based on host requirements rather than network requirements. As I did for the previous video, working through these without having an answer to check yourself isn't very helpful. So I've typed up a little walkthrough for each one of these, essentially the 3 steps we've been working through so far, so that when you finish them, you can compare your answers to what I have. That's available off of nuggetlab.com, and just look for the ccent pack of some sort. It'll be a zip file where you can download all of this paperwork. We've got, after this, one more style of subnetting to show you. And in my mind, it's the easiest, but it's the most common style that's out there. Let's talk about, before we get into the new style, where we've been so far. At this point, you should know how to subnet based on the number of networks. If you were given X number of networks, you can break apart addresses and break them into subnets that meet those requirements. And you should be able to do that for hosts. When somebody says, I need this many hosts per network, then you can work through that, save the hosts, and meet those requirements and come up with the subnet mask and network ranges to deliver. I hope this has been informative for you, and I'd like to thank you for viewing.